welcome to the deep dive.
Yeah.
Today, we're diving into a book you sent in,
Okay.
The Art of Physics by Zahaan Bharmal.
All right.
And you were curious about how physics can help us understand everyday life.
Mm-hmm.
It's not your typical physics textbook.
Right.
Bharmal actually uses his background as a physicist.
Oh, wow.
He's turned into a management consultant.
Okay.
And uses that to explore all sorts of things like getting fired, making tough decisions,
Interesting.
and even facing those midlife crises we all hear about.
Yeah, it's a really clever approach.
Yeah.
Physics can seem pretty abstract, but Bharmal breaks down those complex systems we encounter every day, showing how those same principles apply whether you're looking at a galaxy or even your career path.
Exactly. And he starts with a pretty relatable experience getting unexpectedly laid off,
Oh.
despite working hard and getting positive feedback.
Oh, wow.
I think this is a perfect example of what you wanted to see,
Right.
how abstract concepts connect to real life.
Yeah.
So he was blindsided by this layoff during the dot-com bubble burst back in 2001.
Right.
But instead of just focusing on the personal setback, he zooms out to look at the bigger picture.
He uses this idea of self-organized criticality.
Sorry.
It's a physics concept that he illustrates with a sand pile.
Right.
So imagine you're slowly adding grains of sand to this pile. It seems stable for a while,
Okay.
but eventually just one grain
Yeah.
can trigger this massive avalanche.
Whoa.
Bharmal says this is kind of what happened with the dot-com bubble.
Okay.
Things seemed fine on the surface, but the system was actually building toward this critical point
Right.
where even a small trigger could just cause a collapse.
Okay, that's a great visual.
Yeah.
But what does this sand pile had to do with me losing my job?
Well, it's about understanding that unpredictable events are often the result of underlying instability in complex systems.
Yeah.
Bharmal argues that just like that sand pile, seemingly stable situations can be more vulnerable than we realize.
Okay.
And he goes on to connect this idea to other events, like
Right.
the subprime mortgage crisis and even stock market fluctuations.
Right, so the point isn't to predict these avalanches,
Right.
but to be prepared for them.
Yeah, exactly.
So how do we prepare for the unpredictable?
Well,
Do we all need to become physics experts?
not exactly. Bharmal talks about building what he calls surge capacity.
Surge capacity.
Yeah, it's kind of like having an emergency fund.
Okay.
But for like all aspects of your life,
Okay.
it could mean having some financial cushion, a strong support network you can lean on, or even just a mindset that allows you to adapt quickly to change.
So it's about having those backup resources ready in case things go sideways.
Right.
I can definitely see how that would apply to like a sudden job loss or even a global pandemic.
Exactly.
It's not about living in fear, but being prepared.
Right.
Okay, what else does he apply this physics lens to?
Well, he moves on to something we probably all struggle with. Making decisions, especially when things feel uncertain.
Decisions, okay.
And he actually ties this to quantum physics.
Wait, quantum physics?
Yeah.
Isn't that all about subatomic particles and stuff?
Yeah, but...
How does that relate to deciding whether or not to take that new job?
Right, it sounds like a stretch.
Yeah.
But stick with me.
Okay.
Bharmal starts by talking about his own dilemma of whether to take a temporary government job that had a lot of unknowns attached to it.
Okay.
And he connects this to the uncertainty principle in quantum physics.
Uncertainty principle.
Yeah, which basically says you can't know both the position and momentum of a particle with perfect accuracy.
Okay.
There's always some inherent uncertainty.
So there's always a little bit of unknown.
Yeah, and then he goes on to talk about superposition, which is the idea that a particle can exist in multiple states at once until it's observed.
Okay, I'm starting to see where he's going with this. So he's saying that making decisions is kind of like being in a state of superposition.
Yeah.
Where we're weighing different possibilities.
Right.
And it's only when we make a choice that one outcome becomes real.
Exactly.
But how does quantum physics actually help us make better decisions?
Well, Bharmal suggests this field of quantum cognition can actually improve our decision-making.
Quantum cognition.
Yeah. Basically, researchers are applying the principles of quantum mechanics to understand how our minds work, especially when making choices.
Okay.
And they've found that these quantum models often predict real-life decisions more accurately than traditional models based on pure logic and probability.
That's wild. So you're saying that our brains might actually be using quantum principles to make choices?
Yeah, it's a pretty radical idea.
But how does that actually play out in everyday life?
Well, Barmal gives a few examples.
Okay.
There's this classic experiment called the Linda problem that shows how we often make judgments based on what feels intuitively right, even if it contradicts basic probability.
So we go with our gut.
Yeah, it's like we're drawn to narratives even if they're statistically less likely.
Interesting.
He also talks about studies where quantum cognition accurately predicted hiring decisions.
Hiring decisions?
Yeah, based solely on photos.
Wow.
While traditional models failed to capture that human element.
So instead of trying to be perfectly rational,
Right.
which we know isn't always possible,
Yeah.
maybe we should embrace the fact that our brains might be working on a quantum level with all its inherent uncertainty.
Exactly. But Varmal suggests that by acknowledging this uncertainty and preparing for multiple scenarios, we can actually make more informed and decisive actions.
So it's like using the uncertainty to our advantage.
Yeah, kind of turning it on its head.
Okay, so that's getting fired and making tough decisions. What other everyday experiences does he tackle?
Well, he delves into something that's both incredibly personal and a huge global issue, having less.
Having less.
Okay. He starts with a personal anecdote about feeling inadequate compared to his wealthier colleagues.
Okay.
And then he juxtaposes this with the contrasting scenes of celebration during Lender's 2012 Olympics bid and the protests surrounding the G8 summit, which was focused on poverty.
Right.
It's this stark reminder of the vast disparities that exist in the world.
Yeah, it sounds like he's tying personal feelings of inadequacy to the broader issue of wealth inequality.
Yeah, exactly.
But how does physics fit into all of this?
Well, he makes this fascinating connection back to the origins of the universe.
The origins of the universe, okay.
You see, those tiny quantum fluctuations in the early universe, those tiny variations in energy density, actually set the stage for the formation of stars and galaxies.
Okay.
In a way, he's arguing that inequality is baked into the very fabric of the cosmos.
Wow. Okay. I did not see that coming.
Yeah, it's a pretty mind-blowing idea.
So the universe itself started with some level of inequality.
Right.
But how does that translate to, say, the gap between the rich and poor?
He introduces this idea called the constructal law.
Constructal law.
Yeah, developed by Adrian Bejan, who is a mechanical engineer.
All right.
And it basically states that flow systems naturally evolve towards greater access.
Okay.
Think about a river delta.
All right.
Water flows in a way that maximizes its reach and distribution.
Oh.
Bejan argues that this same principle applies to pretty much everything.
Everything.
Including the flow of wealth in an economy.
So he's saying that inequality is sort of inevitable in any system where resources are flowing.
Yeah, it's kind of like that river. It's always going to have branches and tributaries, some bigger than others.
But does that mean we should just accept inequality as a fact of life?
Not necessarily. Bejan emphasizes the importance of ensuring fairness in how those resources are distributed.
Okay.
And Varmal picks up on this and argues that things like progressive taxation and targeted social programs are ways to influence that flow.
Okay.
And create a more equitable distribution of wealth.
So it's like we could use these physics-inspired principles to not only understand why inequality exists, but also to think about solutions.
Exactly.
We can be aware of the natural flow, but also recognize that we have a role in shaping how that flow impacts people's lives.
Yeah, it's about understanding the system and then figuring out how to work within it.
Okay, great.
Now, are you ready to dive into another section?
Yeah, let's do it.
All right, Barmal has some really interesting thoughts on climate change.
Okay.
And how our economic models might be leading us in the wrong direction.
Okay, I'm curious to see how physics helps us understand something as big and complex as climate change.
It's a fascinating connection, yeah.
All right, let's go.
So this section is called The Physics of Going Nowhere. And it really resonated with me.
Okay.
Barmal talks about his time working at the World Bank in Washington, D.C., and how he felt this sense of stagnation.
Stagnation. Oh,
like he was going nowhere.
All right.
Both literally in the oppressive D.C. heat and figuratively in trying to tackle this huge issue of climate change.
Okay.
He was tasked with writing a report on the Kyoto Protocol.
Right, the Kyoto Protocol.
Which, as you know, was an international agreement to reduce greenhouse gas emissions.
Right.
But he was struggling to see how we could make real progress.
So it sounds like he was feeling pretty stuck.
Yeah.
Both personally and in terms of seeing a path forward on climate change.
Exactly.
So how does physics come into play here?
Well, he starts by talking about the Earth's energy balance.
Okay.
And the greenhouse effect. That's the process where certain gases trap heat in the atmosphere,
Right.
which is, of course, the core issue behind climate change.
Yeah.
But then he introduces the work of this physicist,
Right.
Robert Ayres,
All right.
who had some pretty strong criticisms of traditional economic models.
Interesting.
Ayres argued that these models completely ignore energy
That's interesting.
as a crucial role.
We usually think of energy as just one commodity among many, like oil or coal. What do you mean by saying it's been ignored?
Well, Ayres argued that energy isn't just a commodity.
Okay.
It's a fundamental driving force behind all economic activity. Everything we do, from growing food to manufacturing goods to transporting ourselves, requires energy.
Yeah.
And yet, traditional economic models tend to treat it as an afterthought.
Okay.
They assume we'll always have enough energy to fuel our growth without really considering the limitations or consequences of our energy choices.
So is he saying that our economic models are built on a faulty foundation?
Yeah, in a way he is.
That we need to rethink how we measure growth and progress.
Exactly. Ayres introduced these concepts of exergy and anergy.
Exergy and energy.
Exergy is useful energy, the kind that can actually do work.
Right.
Energy, on the other hand, is wasted energy,
Well,
the heat that dissipates into the environment, for example.
Yeah.
Ayres argued that sustainable economic growth depends on maximizing exergy use while minimizing energy.
So it's not just about using less energy.
Right.
It's about using it smarter. Right. Like making sure we're not wasting energy on processes that aren't actually productive.
Exactly. And Ayres challenged this assumption.
Okay.
That innovation will always lead to greater efficiency.
Okay.
He argued that while technology can improve, there are limits to how much we can optimize energy use.
Okay.
We need to be realistic about those limits.
Yeah, that's a really important point. It's easy to assume that technology will solve all our problems.
Yeah.
But maybe we need to be more mindful of how we're using energy in the first place.
Right.
So tying this back to Bharmal's experience in D.C., it sounds like he was struggling with this disconnect between the urgency of climate change and limitations of our current economic systems.
He was, and he realized that simply replacing fossil fuels with cleaner energy sources might not be enough.
Okay.
We might need to fundamentally rethink how our economies function and how we measure progress.
Okay, so that's climate change. What's next on Bharmal's physics tour of life?
Well, he takes a turn into something we can probably all relate to on a personal level.
Okay.
Breakups.
Breakups, sorry.
The section is called The Physics of Breaking Up.
Okay.
And he starts by talking about his own dating history.
Okay.
And compares good and bad relationships to stable and unstable systems in physics.
That sounds familiar.
Yeah.
We've all been in those relationships that felt rock solid.
Right.
And others that were, well, a bit more volatile.
Yeah.
How does he use physics to explain this?
Well, he uses the simple but effective analogy.
Right.
Imagine 2 balls in a valley.
Okay.
They're stable, right?
Yeah.
Now imagine 2 balls on a hill.
Okay.
One little nudge and they're going to roll away from each other.
Right.
He says good relationships are like those balls in a valley. There's a natural stability there.
Okay.
But those volatile relationships are like those balls teetering on a hill. Any little thing can send them flying apart.
Okay, that makes sense.
Yeah.
But he doesn't stop at just romantic relationships, right?
No, she doesn't.
I remember reading something about Brexit in this section.
You're right. He connects this idea of stability to the 2016 Brexit referendum.
Okay, Brexit?
Remember how all the polls predicted a Remain win?
Yeah.
It seemed like a sure thing.
Yeah.
But then the Leave campaign won.
Right.
Which shocked a lot of people.
Yeah, it did.
Bharmal uses this as an example of how even systems that appear stable can have underlying instabilities that we might not be aware of.
So even political systems can be like those balls on a hill.
Exactly.
It seems like everything we think is stable might actually be teetering on the edge of chaos.
Yeah, it's a thought-provoking idea.
It makes you wonder what other seemingly stable systems are actually more fragile than we realize.
Right, and he then brings in the work of a physicist named Alex Siegenfeld, who actually studies the physics of democratic instability.
The physics of democratic instability.
Yeah, it sounds a little out there, but it's actually pretty fascinating.
Okay, I'm intrigued. How can you apply physics to something as complex as democracy?
Well, Siegenfeld argues that even small shifts in voter preferences can lead to huge changes in election outcomes.
Okay.
He uses this image of a bell curve to explain this.
Right, the bell curve.
So imagine a bell curve representing voters' political views.
Mm-hmm.
When most voters are clustered near the center,
Yeah.
the system is relatively stable.
Okay.
But when voters become more polarized, that bell curve starts to look more like an M shape.
An M shape.
Yeah. With peaks at the extreme.
Okay.
You see what I mean?
So when you have those two peaks on opposite ends of the spectrum,
Yeah.
even a tiny shift in the middle can create a massive swing in one direction or the other.
That's the idea, and Sienefeld argues that this is what's been happening in U.S. presidential elections since around the 1970s.
Okay.
The system has become more polarized, more like that M shape, which makes it more prone to these wild swings back and forth.
So what can we do about it?
That's the big question.
Yeah. Is there a way to bring that bell curve back to a more stable shape?
Well, Bharmal doesn't really offer any easy solutions.
Okay.
He's more focused on helping us understand the dynamics at play.
Okay.
He also introduces this concept of negative representation.
Negative representation.
Which is the idea that small changes in public opinion can actually lead to results that are the opposite of what you'd expect.
Opposite.
Yeah, it's a bit counterintuitive.
Yeah.
But it just shows how complex and sensitive these systems can be.
So understanding these dynamics of stability and instability is crucial.
Yes.
Not just in our personal relationships, but also in the broader political landscape.
Exactly.
It's about being aware of those underlying forces that can shape outcomes in ways we might not expect. Okay, what else does Bharmal explore?
Well, he delves into something that might seem a bit more niche, but it's actually really interesting.
Yeah.
Language. The section is called The Physics of Not Fitting In, and he starts with a personal story about moving to York and feeling like an outsider because of the differences in accents and dialects. Yeah, between northern and southern England.
The age-old battle of accents.
Right.
I can definitely relate to that feeling of being out of place because of language.
Yeah.
But how does he connect this to physics?
He talks about how physics can be used to study and predict language change.
To predict language change, okay.
He introduces the work of this physicist, James Burridge, who uses concepts like surface tension and bubble dynamics to model how dialects evolve.
Wait, bubbles?
Yeah.
Like soap bubbles. What do bubbles have to do with language?
Oh, it's all about how languages spread and interact.
Okay.
Think about how soap bubbles expand and sometimes merge with each other.
Okay.
Burridge argues that linguistic boundaries, or isoglosses, behave in a similar way.
Okay. They can expand and contract, and sometimes they merge as languages influence each other.
So the way we speak is kind of like a constantly shifting landscape of bubbles.
Yeah, that's a cool way to visualize it.
That's a really cool way to think about it.
Yeah, and Burridge found that factors like population density and social interactions play a big role in how these bubbles evolve.
Interesting.
He even studied bird dialects.
Bird dialects. Whoa.
And found that the death rate of birds influenced the disappearance and reappearance of certain dialects.
Wow.
It's like this complex interplay between language and the environment.
So are we all just speaking in bubbles? That's a pretty wild thought.
Yeah, it's a different way to think about it.
What else did Bharmal find interesting about this connection between language and physics?
He highlighted this really interesting correlation between linguistic diversity and biodiversity.
Linguistic diversity and biodiversity.
Yeah, he suggests that studying language data could actually give us insights into areas that need environmental protection. Wait, so the way people speak can tell us something about the health of the environment?
Yeah, it's a fascinating idea.
How does that work?
Well, if you think about it, languages often evolve in close connection with the natural environment.
Right.
So the decline of certain dialects or languages might be a sign that the ecosystems those languages are tied to are also in trouble.
Oh, wow.
It's like using language as a barometer for environmental health.
That's fascinating. It makes you realize that language isn't just about communication.
Right.
It's also a reflection of our relationship with the world around us.
Exactly.
Okay, I think we have time for one more section before we wrap up.
Right.
What's Bharmal's final physics of life exploration?
Well, this one hits close to home for a lot of people, I think.
Okay.
So this last section is called The Physics of a Midlife Crisis.
Okay, midlife crisis.
Now, I'm not quite at that stage yet,
Right.
But I've definitely heard the term thrown around.
Yeah.
What's Bharmal's take on this?
Yeah, what is it?
He starts by getting personal again.
Okay.
He talks about how Even though he had what many would consider a successful life and career, he still felt this sense of inadequacy. This feeling that something was missing.
Okay.
He calls it a midlife wobble, that feeling of questioning everything you've done and wondering if you're on the right path.
Yeah.
And he connects this to a concept you might be familiar with.
Okay.
The tragedy of the commons.
Oh, yeah. I remember that from environmental science class.
Yeah.
It's the idea that when people act in their own self-interest, it can ultimately harm the common good, right?
Exactly.
Like overfishing, polluting the air.
Exactly.
Yeah.
He uses that classic example of herders grazing their cattle on a shared pasture.
Right.
Each herder wants to maximize their own profits, so they add more and more cattle. But eventually, this overgrazing destroys the pasture, leaving everyone worse off.
Right, so they all lose.
Exactly. And Bharmal suggests that we see this same dynamic play out in all sorts of social situations.
So he's saying that even if we think we're making rational choices, those choices can have unintended consequences that ripple out and impact everyone.
Right. He even connects this to things like vaccine refusal. And the COVID-19 pandemic.
Okay.
Even though individuals might have their reasons for not getting vaccinated, those choices can have broader implications for public health.
Yeah, for sure.
It's like those herders adding more and more cattle, they're not necessarily thinking about the long-term consequences.
That's a really thought-provoking way to look at it.
Yeah.
It makes you realize how interconnected we all are, even if we don't always see it.
Yeah.
So is that where he leaves it? Just this idea of the tragedy of the commons playing out in our lives.
He actually goes a step further.
Okay.
And introduces the work of Peter Turchin, who studies historical dynamics using mathematical models.
Using math, all right.
He's kind of like a historian who uses math to understand how societies evolve over time.
Okay, that sounds pretty complex.
Yeah.
What exactly is he studying?
Turchin focuses on these long-term cycles of stability and instability in societies.
Okay.
He calls them secular cycles. And they typically span a century or more.
Wow. Over 100 years.
Yeah. And he's found that these cycles are often driven by things like overpopulation, declining living standards, and an overproduction of elites. Basically, too many people competing for limited resources and power.
So it's like a societal pressure cooker.
Right.
And eventually, something has to give.
Exactly. And the scary part is that Turchin has actually used his models to make predictions about the future. Based on his analysis, he warned of increased social unrest in the United States. Based on these historical patterns.
Wow, that's pretty unsettling.
Yeah.
So knowing all of this, how are we supposed to navigate these cycles?
Right.
Are we just doomed to repeat history?
Well, Bharmal doesn't necessarily offer any easy answers. He's more focused on helping us understand the forces at play.
Right.
But he does suggest that recognizing these cycles can help us make better decisions. Both individually and as a society. If we know that certain conditions tend to lead to instability, maybe we can take steps to mitigate those conditions, or at least be prepared for the consequences.
So it's like having a roadmap.
Yeah.
Even if it's a bit rough around the edges.
Right.
To help us navigate those inevitable ups and downs.
Exactly.
It's not about predicting the future with perfect accuracy.
Right.
But about understanding the patterns and being better prepared to deal with them.
And I think that's one of the key takeaways from Bharmal's book as a whole.
Yeah.
He shows how physics, which can seem so abstract and disconnected from our everyday lives, actually provides a powerful framework for understanding the world around us and even ourselves.
I totally agree. It's like he's given us this new lens to look at things.
Yeah.
From getting fired to falling in love.
Right.
From tackling climate change to facing those midlife crises.
Exactly.
And it's not about having all the answers.
Right.
But about embracing the questions and using these physics of life principles to navigate the complexities of the world.
And, even though he covers some pretty heavy topics, there's also this sense of optimism running through the book.
Right.
He doesn't present physics as this deterministic force that dictates our destiny. Instead, he emphasizes that we have agency.
Right.
We have the power to make choices that can influence outcomes.
Right. It's like he's saying, here are the forces at play.
Yeah.
But you're not just a pawn in the game.
Right.
You have the ability to make moves to change the course of things.
Yeah.
And I think that's a really empowering message.
Yeah. I agree.
Especially in a world that can sometimes feel overwhelming and out of our control.
Absolutely. So as we wrap up our deep dive into the art of physics,
Yes.
I want to thank you for suggesting this book.
Yes, thank you for sending this in.
It's been a truly thought-provoking journey.
We've covered a lot of ground today, from sand piles to black swans.
Yeah.
Quantum cognition to the tragedy of the commons.
Yeah, we've been all over the place.
It's amazing to see how these seemingly disparate ideas all connect in ways we might not have imagined.
And to leave you with one final thought from Bharmal.
All right.
He says, even though we may never fully unravel the mysteries of the universe, the pursuit of understanding is what makes life truly fascinating.
So keep asking those questions, keep exploring those connections.
Yeah.
And keep looking for those physics of life moments in your own experiences.
Exactly.
You never know what insights you might uncover.
Right.
Until next time, keep diving deep.